All right, let me go ahead and turn on my camera and yeah, let's go ahead and we'll get started here in about a minute, but I'm super excited about this dealer training. My name is Kyle Miller with DJI, and we're here to talk about the Mavic 3 Multispectral. All right. Once it hits 10:02 Central Time, we'll go ahead and get started. But just a couple housekeeping things before we do actually get started. There is a section for questions, so feel free to put some of the questions that you have. Maybe you've already got some prepared. Go ahead and put those in the questions box. We should have some time at the end for questions and answers, and there will probably be some duplicates, so go ahead and get those in. If you can't hear me, if you can't see me, if something's going on, feel free to message in the chat down at the bottom, and hopefully we're going to be able to catch that. But I think audio visual looks good on my part. Perfect. All right, well, let's go ahead and get started. With a brief introduction, my name is Kyle Miller. I'm a solutions engineer at DJI. I'm on the enterprise team. And my background is agriculture as well, so this product is really hitting near and dear to my heart. I'm based in Eastern Iowa, grew up on a corn and soybean farm, and my parents still farm, still definitely helping out come planting and harvest. Now it's definitely a little bit slower time of the year, which is perfect for being able to do some of this work. Been at DJI now for about 9 months, and previously worked at Drone Deploy and then also Ag Eagle in the back, making fixed wing drones. So let's go ahead and get started about the final iteration, the one that we've all been excited about for agriculture of the Mavic 3 Enterprise series, which is the Mavic 3 Multispectral. All right. We're going to walk through a couple different topics. The first one being talking about the actual product. How is it different than the Phantom 4 Multispectral? How is it different than the Mavic 3 Enterprise? What does the multispectral payload entail? And then also getting into the solution introduction. So basics on understanding plant health, understanding different indices and capturing near infrared very accurately, looking at NDVI. And then we'll walk into some of the multispectral specific use cases. And then at the end, we do have a member of our support team, hopefully. I don't see them on the staff, so hopefully they join in at towards the back half of the hour, and we'll talk a little bit about DJI care and maintenance with these Mavic 3 Multispectrals. Well, let's go ahead and get started. So an introduction, the Mavic 3 Multispectral is that new version, that new iteration of the Phantom 4 Multispectral that has now been on the market for well over 2 years, I believe even 3 years. So it's a much needed upgrade. We'll talk a little bit more about the specific sensors, but what I am the most excited about with this platform is no longer having to choose between spatial and spectral resolution and accuracy. So with the Phantom 4 Multispectral, we got great spectral accuracy. There was 2 megapixel, but we were capturing those bands of light very accurately for analysis. But we are missing the big spatial resolution problem. We had a low resolution visual camera. We do have a lot. We can check that box off with the Mavic 3 Enterprise, the Matrice 300 and P1. You know, DJI is known for having high quality spatial resolution and accuracy, but can we combine those into one drone so you don't have to have multiple drones for this workflow? Breaking down the actual payload, we have 1 main RGB visual shooter and then 4 multispectral sensors capturing each different bands of light. We'll talk about those specifically. You're going to be getting vegetation indices, so the NDVI, as well as visual real time as the drone is flying. So you're getting that onboard processing. Then those imagery that's going to be saved to the SD card can either be used via SDK, Cloud API, or just popping the SD card out of the drone and being able to make high quality 2D orthomosaics and even 3D models with this drone. And you're going to be able to provide customers for those integrated solutions for all things agriculture, plant health, even getting into cattle monitoring and progress there. So a couple different use cases that the M3M can be used for. Overall, though, it can be used just like a Mavic 3 Enterprise to do that survey work. And why is that? Well, we're keeping that same quality of sensor that the Mavic 3 Enterprise has. So it's a compact and portable design, much like your Mavic 3s. I mean, the shell, the body is basically the same. It's something that you've grown to know and love. Yes, we all love our Phantom workhorses, but being able to throw it in the back seat rather than the back of your pickup, or being able to carry it on a plane very easily, it's just so lightweight and portable. We're also looking at a 42-minute maximum flight time with the RTK. I apologize right off the bat. I am a little bit sick, so I do sound a bit nasally. Apologize. But you're going to be seeing that nice improved flight performance over the Phantom 4 line, the Phantom 4 Multispectral. So, even as we look at the Mavic 3 Enterprise and we look at the Mavic 3 Multispectral, you get that 42 minutes of maximum flight time. We're seeing a lot of people making mapping missions of 30 up to 34 or 35 minutes, whereas the Phantom 4 RTK and the Phantom 4 Multispectral had 28 minutes of flight time, I believe. You're planning missions for about 20 minutes. So in theory, you're planning about 50% longer missions, as well as flying faster, and we'll be getting there too. But it also has that 20 megapixel 4/3 inch CMOS visual camera, same as the Mavic 3 Enterprise, same focal length, everything like that. But we wanted to include that because we found so much need of running machine learning for different use cases, and it wasn't always using the spectral bands of light. Maybe high resolution spatial, high resolution and training machine learning on the individual leaves based off of a certain type of stress or identifying plants. We needed something with higher GSD and a much larger sensor so we can have a lot more contrast within the imagery. So we've got a nice big sensor. We do have 4 multispectral sensors. Those are 5 megapixels each. We did drop the blue band, but we didn't find as much value for that, and we found more value having a much higher resolution RGB. And so the 4 sensors that are on there are capturing green, red, near infrared, as well as red edge. I kind of did it out of place there. But you're going to be able to capture all the bands accurately to produce the majority of the indices that you're working with. We also have a sunlight sensor, and that's going to be replacing the back end of the drone. You'll see on a later picture that it's actually different than the M3E because that's a beacon. We took the beacon off. You can also add third-party beacons on pretty easily. We've seen people do that, but we replaced it so that we have an incident light sensor or a sunlight sensor, and we'll be talking about why that is so valuable in just a moment. We also have the industry-leading O3 transmission. So these very large sites, even if we're in areas of not much noise, I mean, here in Eastern Iowa, we don't have very much noise. We're not in very urban environments, but we are flying quite a ways away from where we potentially are. We always want to maintain line of sight, but DJI, we've got that nice transmission so that you're always maintaining good FPV back to the drone. And then obviously the RTK module. It's really valuable, and it's something that is absolutely needed within agriculture, especially when you get into plot and micro plot analysis and making sure all of those plots align perfectly or near perfectly. Having RTK on board is such a lifesaver. Let's take a look a little bit more at that RGB camera. It's very similar, the same as your Mavic 3 Enterprise. It's going to be capturing imagery at 0.7 seconds, so you're going to be seeing the same flight speeds that you're seeing with the Mavic 3 Enterprise, blazing through those fields, really getting the work done rather than the Mavic or rather than the Phantom series. So all of it is microsecond time sync. So when it takes the image, it logs the RTK location and it saves it to the image. And a lot of this you probably have seen before. It's got a mechanical shutter. It is the same camera as the Mavic 3 Enterprise, and that's, I know that it sounds like I'm maybe not as excited saying that it's just the same, but I am blown away that we actually brought that same size of sensor and multispectral. It's going to be a really big workhorse for agriculture. So with that normal camera, you can go out there and map just like a Mavic 3 Enterprise. We've got a lot of customers outside of the ag space that do want to have a multispectral drone in their fleet, whether it's for right-of-way inspection with pipelines, with transmission, active job sites. You need that environmental restoration, and you need to be able to capture that with near infrared, with red edge, so that you can run the different indices to understand after you're done at the job site, are you back to restored to where you were? So we wanted to make it so you didn't have to sacrifice spatial accuracy and resolution. Now you can just use this as a normal mapping. And hey, if there does need to be vegetation analysis, yeah, we'll check out the variable zoom camera, but now we'll have the same M3E and an M3M essentially together. So you can kind of see some of the stats. Oops, you can kind of see some of the stats there about that, about the main shooter. Let's keep moving. We do have real-time terrain follow. This is something that we're also seeing in the Mavic 3 Enterprise and the Mavic 3 Thermal now as we roll out, but we wanted to make sure to roll it out within the ag drone, within the multispectral drone, because we're often flying over very hilly terrain. And so as of now, we can either use terrain following, fly it beforehand, upload a DSM, a digital surface model, to refly, and it's really cumbersome. But now we can actually just use the obstacle avoidance sensors on the drone, and it'll be actively following the terrain to be able to capture that site and be able to capture the same GSD across the entire site. So the terrain follow range, it is a bit higher right now. Lowest is 80 meters, so the 200 and some feet. But for hilly areas, Western Iowa, for example, where we get a lot of contours and terraces, or you do have 200 feet of elevation change, even if you're flying at 300-400 feet doing that typical mapping mission for agriculture, it's going to be very valuable to be able to just turn this on with a button. No more extra magic that you need to do, and it's just boom, real-time terrain follow, no internet connection, no extra DSM that you have to produce. Oh, there's a video. Shoot, I should have had that playing. Well, let's keep moving because I am a little bit behind here. So let's dial into, we talked about the RGB camera. Let's also now talk about those visual cameras. So, or not the visual, the multispectral cameras, I apologize. So we are capturing green, red, near infrared, red edge. Feel free to take a screenshot here if you want to. Those are the specific bands of light that we are going after. Also, you can see it's plus or minus about 16 nanometers. So if you're trying to understand what the accuracy is of these sensors, we are pretty dialed into those specific bands of light. So as you can see on the top, replacing that telezoom camera that you have in the Mavic 3 Enterprise with 4 smaller sensors that are capturing each individual band. Once again, they're 5 megapixel, and you can see they're 1/2.8 CMOS sensors. Now, let's talk about that sunlight sensor, or also known as an incident light sensor. What happens throughout the growing season, just a little bit of background, you can fly over a field and be able to do some trend analysis pretty easily, flight over flight, or even within the same flight, you can have varying sun conditions. Now, it's difficult to be able to adjust for that in post-processing, but if you have something real time that's able to read what the ambient light is, it can adjust the sensor accordingly and make sure that we're capturing it so that when we go out tomorrow, even if we're flying maybe at a little bit different time of day, so the angle's a little bit different, or it's a little bit more overcast than what it was perfectly sunny yesterday, now all of your data is going to be able to be trackable and traceable over time and take out that variable of sunlight. So it's kind of an ambient light sensor reading in what that ambient light is, adjusting the sensor, and it is a big improvement over the Phantom 4 multispectral. The Phantom 4 multispectral, if you held it up to the sun, there's kind of a triangle at the very top of the RTK module, which was the incident light sensor, but it was flat. And because it was flat, we were having problems with striping. And so we were recommending you fly in a certain pattern, a certain orientation, depending on what the sun was and the time of day. But now we no longer need to do that because we're actually being able to get ambient light from not just straight up, but then also from all different angles, because it's kind of hanging off the back, and we have a much larger field of view here. So no longer having to adjust your flight plan heading accordingly. You can just fly it the most efficient way possible. We also support calibration panel. That is something that you will need to be purchased separately. Currently, we are relying on third-party platforms, manufacturers to build those, but if you capture it, you take a couple ground-based photos over that panel and you have the correct values for the panel that whoever manufactured it, you can then put that into Terra, do the adjustments, and be able to use a calibration panel. We had a lot of customers asking about not just an incident light sensor. Yeah, and also a nice view to be able to understand real time, maybe be able to scout real time if you do see something pop up. We are processing a NDVI, basically a plant health indice, right on board of the drone. And so much like you have thermal side-by-side on some of the other drones that you may have flown before, we're able to use the side-by-side tool. I'm not sure if you're able to see my mouse. I'm going to try to probably not, but you can see up next towards the NDVI values, if you hit the SBS button, that's going to put both of those views together. So you can get that real-time plant health in the field, and you can even do this during manual flight. If there's a low area or a problematic area, you could just go and fly it and manually understand, well, this area seems to be darker on the NDVI scale, or it seems to be more green here. So being able to get real readouts, real time, when you're going out and mainly scouting, that's going to be very, very helpful. And our O3 transmission. It's within the drone, we have 4 different antennas, 2 transmitters, 4 receivers. Then also on the controller, we've got different antenna. We're seeing a range of about 9 to 15 kilometers with low interference. That's most of the environments that we're going to be flying this drone in are going to be low interference areas, but because it's DJI and we have that industry standard, industry leading transmission range and transmission quality, I mean, that's one of the major things that sets DJI apart. That transmission is going to be super helpful. No longer are we back in the day writing waypoints to a drone and sending it off and hoping that it comes back. We're making sure that we stay connected the entire time, even in those little bit difficult environments, even if we are flying quite a bit lower, trying to do plot level analysis, even if we are a decent ways away. So O3, big improvements there. We also have omnidirectional obstacle sensing. So again, I'm getting a little bit nasally, I apologize. But we have 6 different sensors, 6 different video cameras on board that are being used for obstacle avoidance. We also have different radar sensors on there as well. So we're not just using RGB or visual cameras, meaning we can detect obstacles at night, which is great, not quite as accurately, but either way, you're going to be able to use our trusted obstacle avoidance to be, a lot of these flights, especially if you look at plot level flights, they're going to be fairly low. We're looking at very high levels of ground sampling distance, or GSD. And so when you're flying that low, oftentimes you have tree lines. I hate to even say power lines, because I really wouldn't trust all of our obstacle avoidance necessarily around power lines. I don't really trust anyone's obstacle avoidance around power lines. So just be cautious there. But tree lines, buildings, shops, grain facilities, things like that, being able to trust the drone and being able to fly and avoid those obstacles. We also have advanced return to home. Right now, it is for manual flight. We are looking to integrate that into mapping conditions as well. So as we launch this drone, this is manual. for manual flight only, but if you are flying it manually and you hit the return to home button, it's not just going to come home and turn off obstacle avoidance. It's not just going to come home and if it does see something, stop. It's actually going to come home and find its own way home if there are obstacles in the way and be able to come back safely to your location. So we do have that advanced return to home function mainly within manual flight now, hoping to incorporate that into mapping missions. And then we do also have APAS 5.0. So that's also, once again, trying to make it back home, find the best route home possible in those really tricky environments. Once again, it's pretty often that we're flying in tricky environments. If we're doing production agriculture, sure, flying a lot of 300, 400 foot flights, being able to cover as much acreage as possible. But if we're looking at research and really utilizing those multispectral sensors, a lot of much lower flights. So it's that, once again, really pounding on that DJI trusted industry leading, industry holding source of technology here. And some accessories, things that you can either purchase later or that even come in the box. So we have the same controller as the Mavic 3 Enterprise, the Mavic 3 Thermal. You have the RC Pro Enterprise. There's no standard and smart controller. They all come with a smart controller, has incredible amount of nits brightness. So it's about blinding when you're inside. So when you're outside on those really hot, really bright sunny days, you're going to be able to see it much, much easier than an iPad. Three-hour battery life. There is no external battery like you're seeing on the M30 or the M300s, but it's a USB-C, so you can charge that up pretty quick. The main difference between the RC Pro Enterprise and just the RC Pro that's coming with the consumer Mavic 3 is that this has mini HDMI out. So if you are trying to be able to just show what you're doing while you're flying, it's perfect for just hardwired that in. I should have cleared out the cellular module. It's something that, since this is the US training, we are not, at least this portion, there are going to be later trainings that this may be recorded, but just know in the US, the cellular module is not available. But the other advantage is you do have a built-in microphone, whereas the standard RC Pro does not have a microphone. We'll get to why in just a moment. And then the RTK module, it's the same RTK module that you can buy for the Mavic 3 Enterprise, the same lot number or product number. Now to note, you are getting a Mavic 3, or you are getting an RTK module standard in all of your Mavic 3 multispectrals. So you don't have to buy the drone and then the $750 add-on. You get it because we found so much value of needing high accuracy here. You get it in the box with the drone, which is great. And then speaker, there is the option if you want to take off the RTK module, maybe for more cattle, more pasture, trying to be able to check in. You can buy the speaker and you can use that on the Mavic 3 Multispectral. The controller is going to have that microphone. So if you are trying to communicate with something else, someone else, some being, a cow, whatever it would be, you're going to be able to utilize the speaker. Not as important though as what we found with the Mavic 3 Multispectral. Really focus in on that RTK module. And then the professional software. So there's 3 different pieces of software that we're going to be able to utilize with the Mavic 3 Multispectral. First one is capturing the data. It's the same Pilot 2 app that you may have been familiar with the Matrice 300 series, the Matrice 30 series, and now the Mavic 3 Enterprise series. There's a lot of different flight plans within the Pilot 2 app. So if you're doing just general mapping missions, that's something that's super easy that we're going to be able to do. But those more complex flight plans, you could do waypoint mission planning with a Mavic 3 Multispectral. You can also do corridor flight plans. I talked a bit about the use cases outside of the specific ag industry, talking about environmental aspects and remediation, getting back that job site, getting back to 100% after it's been dug, whatever that case may be. So let's take a look at Transmission lines, let's take a look at pipeline inspection. So many different linear things that we don't need to just map with high resolution RGB, but there are environmental impacts that we're gonna need to understand the plant health. And getting that just off the RGB camera can be possible, but if you want something the most accurate, now all you have to do is just make sure those bands are turned on and you can be able to do corridor missions. Even if you're using this as a normal mapping drone and there's the smart oblique function that's controlling the camera's gimbal while it's flying to capture not just nadir, but oblique imagery. You have that same functionality on the Mavic 3 Multispectral. It is a mapping drone, much like the Mavic 3 Enterprise, but we are able to capture those extra bands if you do turn them on. So a lot of the same functionality that you have seen out of that Pilot 2 app that's going to be loaded on the controller. And then when it comes to processing the data, when you are looking for the 2D orthomosaics, being able to view the plant health, being able to process into a 3D model, and being able to export any of that data out, we do have DJI Terra. It does support multispectral reconstruction with the Mavic 3 Multispectral and other previous versions. Just note here, if you do purchase the Mavic 3 Multispectral kit, you are getting a DJI Terra full license, one user for 3 months. When you first register the drone, it will just turn on a free account, but there should be a code in the box that you can turn on for 3 months. That is specifically the electricity plan, which is pretty much the same as Pro. You're going to be able to process and have all the functionality needed, not just the ag plan. But if you're looking for aspects of fleet management, when you're wanting to know where your drones are, how many drones that you've got, what process the repair, not necessarily repair, but the time frames of being able to check those drones and understanding how long they've flown. A lot of that is going to be captured under DJI Smart Farm. There are going to be other aspects of analysis, such as tree counting or being able to put drop pins on trees, where you're going to be able to utilize Smart Farm to kick out a prescription back out to your Agris spray drone. So if you're wanting to combine all of the software solutions, you've got M3M capture on Pilot 2, processing within Terra, tracking all of the flights within Smart Farm, and then also generating exports and analysis through Smart Farm to kick over to your Agris to be able to then spray. So Mavic 3 Multispectral includes one Smart Farm license for 1 year. And it's the same extensibility that we have seen with the other Mavic 3 Enterprise series. So you get mobile SDK, looking at third-party support. So I'm not sure if we've got any partners in here, if it's all dealers, but we'll go ahead and poke and prod some of those partners again to make sure that we're building out really successful mapping missions with the Mavic 3 Multispectral in 2023. So kind of looking at some of our partners, capturing flight with Pix4D, with Drone Deploy, some of the main usual names. That mobile SDK is supported. So at some point in the future, you may, if you're looking to fly outside of Pilot 2 and your favorite flight app, you may be able to do that with Mavic 3 Multispectral. We also have payload SDK support. So if you're looking to put something else on the drone, utilizing the USB-C port at the very top of the drone, I will say the majority of the time with this drone, it's going to be that RTK module. But once again, since it has the same sensor, the main visual sensor as the Mavic 3 Enterprise, it can be used just as a normal mapping mission drone. And so if there's another payload SDK or payload out there that makes sense to do it, it's going to work on this drone just like it works on the rest of the Mavic 3 Enterprises. So expect to see some of those, expect them to just, once those payloads roll out, to be able to support all the different drones. And then also, we do have Cloud API. So for some of those partners that are looking to, once the mission is captured, maybe even while the mission is going, you're going to be able to utilize our Cloud API to pull in imagery, pull in videos. So if you're looking for live real-time reconstruction, if you're looking to just push all of your data to Pix4D, Drone Deploy, at this point I'm naming them. They don't have the Cloud API integration with this specific drone built yet, but it is out there, it's available, and it's something on the roadmap for a lot of these partners. And it whether it's public, we do have a public cloud API, but if you want to, you can also use it privately. If you have some specific analysis or some specific location that you want to start pushing imagery to, a lot of seed and chemical companies are utilizing our cloud API. Regional restrictions and in the box. Do we have a picture? Yeah. So let's go ahead and just go to the picture because I like those. Very briefly here. Buy your drones. If you're flying in the US, buy your DJI drones in from the US. I mean, it's same thing, same story that we've heard for the past couple of years. There's different FCC guidelines that we need to make sure that we're buying them in North America if we're going to be flying them here. So what comes in the box? With all the Enterprise Series drones, you are getting that hard shell case rather than that side satchel, and something that's going to be much more rugged. You get the 100 watt charger. You can see that box on the side, and that has 2 different USB-C ports, so you can charge the drone's battery and the controller at the same time. And then you can also buy the battery hub add-on if you want to. Got the gimbal cover, micro SD card, a little Allen wrench, main plug for the battery charger. We've got extra sets of props. We obviously have the drone in the kit and the smart controller. But as you can see here, we've got our RTK module as well coming in the box as standard with all Mavic 3 Enterprises. Mavic 3 Multispectrals, sorry. So we're very excited to bring that in the box as well. So I've been pretty long-winded here, but let's talk about how this new drone specifically is an upgrade to the previous drones that we have been flying. If we look specifically at multispectral, the Phantom 4 multispectral, each one of these bands, it does have 6 bands that it's capturing, really 5 in RGB. So we are losing 1 with the Mavic 3 multispectral, but each one of those sensors was 2 megapixels. Now we are bumping each one of our multispectral sensors up to 5 megapixels. So expect the GSD, the ground sampling distance of each one of these, of your plant health maps, to pretty much double just by flying at the same altitude, if not be higher GSD. So big improvements there. Being able to fly higher, get better plant health maps. We have a much larger dynamic range of the Mavic 3 multispectral over the Phantom 4 multispectral. Remember, that RGB sensor was just like the rest of those other sensors, much, much lower resolution and a much smaller sensor size. So now that we have 20 megapixels over 2 megapixels, huge difference. Like I said when I kicked it off, no longer choosing spatial versus spectral. Before it was, well, do I need near infrared? Okay, pull out the Phantom 4 multispectral. But do I need to make a good 3D model or a good 2D map? Probably gonna have to fly it with 2 different drones. But now we can just check the box. It's so much easier. We are, like I said though, we are dropping the blue band on the Mavic 3 multispectral. The RGB camera on the P4 was, 2 megapixels and a 1/2.9 inch CMOS sensor. So spatial and spectral, same time. So happy about this product. Now, comparing the Mavic 3 Multispectral and the Mavic 3 Enterprise, that looks like almost the same image. There are a few key points in here to highlight. One is obviously we're getting rid of the telezoom lens sensor. So you no longer have a 12 megapixel camera set at 144 millimeter focal length so that you're going to be able to zoom in on aspects. If you need the drone for inspection, I would recommend, you're going to need to buy something that has inspection capabilities. With this drone, this Mavic 3 Multispectral is a mapping drone through and through. We replaced a telezoom camera with the 4 individual sensors there. But other than that, the drone is very similar. The only other aspect that I can think of that's different is at the very back, you can kind of tell we replaced that beacon that you get standard on the Mavic 3 Enterprise with the incident light sensor that makes a lot higher, better accuracy multispectral data. It's something that you really need to have on a drone if you're capturing multispectral over time. So we have that on the back now, replacing the beacon, but everything else, if you've got a hard shell case, if you've got stickers that you want to put on it and it fits the Mavic 3 Enterprise or even the Mavic 3 minus the minus the USB-C port on top, it's going to be that same shell of a drone, which is great. It's something that we're all used to at this point. Mavic 3 Multispectral, not quite compatible with Flight Hub 2 yet. Not too many users using Flight Hub 2 with this drone, but if it was a normal mapping mission, they could. We are looking to support that in Flight Hub 2 at some point. All right. I am running a little bit behind, but that is fine. We're getting through a lot of really important information. So let's talk about what is multispectral. Why do we even need a drone to do this when we can just use a normal camera and still generate a plant health map? Why don't we just use the normal Mavic 3 Enterprise? Well, what happens is in the near infrared band of light, when we separate, I almost want to go to maybe this map. Basically, when we look at what our eyes can capture between about 400 and 700 nanometers, the wavelength of light, the distance of light. So from the very dark blues and the purples that we visually see, those are right around 400 to 500 nanometers, the bands of light, the wavelength. When we get into red, that's 700 nanometers plus. And that's just a narrow sliver that our eye can see. When we look at that narrow sliver and what happens with plant health, the difference between red and green and blue bands of light between a healthy plant and a stressed plant, they're actually very similar. And so finding differentiation between a stressed and a healthy plant, it can be very hard to do with the naked eye. Now, once we start seeing the plants start yellowing and actually turning dead, then we do see a difference in the visible bands of light. But at that point, the stress has already taken hold of that plant and it's getting close to that dead state. So even though we can find differentiation of plant health within the visible bands of light, what happens once we get past the red band, essentially once we can't see it anymore, so we get into near infrared before we get into thermal, what happens is the differentiation between healthy and stressed plants separate way far. And so when we have that type of separation, we can create indices like NDVI to be able to colorize that map so we can see that big variation between a healthy plant and a dead plant or a stressed plant, even lightly stressed within the near infrared. We just see much more response within the near infrared and red edge on differentiation between plants. And that's why a lot of people are using that. So you can kind of see on the upper right, you look at the foliar content, it's very, very low between the bands of light we can see. So 450 up to 700, we're not seeing much response. And so if there's a healthy plant or a dead plant in there comparative to a nice, healthy, stressed and a healthy plant, those lines are going to be very, very close together because we're not seeing much reflectivity even in the normal bands of light that we can see. So if the differentiation is there, it is so small. But you see that the green line here absolutely spikes once we get above 700 and 750 nanometers. Because it spikes, and stress plants aren't going to spike as much because there's not as much plant material there, organic matter, there's going to be much larger separation to be able to do much higher levels of analysis. Maybe this map makes the most sense. Maybe I should have jumped to it first. So if you're calculating, there's a couple different types of plants in here. That's what the different lines are. But as you can see, we do have some, while most plants to us look green, that's why it spikes here around 550 to 600 nanometers. It really spikes once we get up to the near infrared bands of light, and not just spike, but we get much larger differentiation between a healthy and a stressed leaf. So that's why we're capturing near infrared. We're trying to get that stress early on before the plant pretty much is close to dead when you start seeing those visible differences. So with sample data, what does data look like out of the Mavic 3 Multispectral? We obviously get the 20 megapixel high GSD out of the RGB sensor, the image that makes sense to us. But since we're only capturing one band of light per sensor, it's essentially going to be a grayscale looking image. So each pixel is going to have its own reflectivity score, reflectivity value, and that's why they then they basically correlate those to a grayscale. But when you start combining it, near infrared and red, for example, if we're calculating NDVI, or if we start understanding the differentiation between the red and the red edge image, or the red edge image and the near infrared image, that's where we're starting to get into indices. So we compare individual bands of light that were captured and be able to correlate them here. So the calculation, NDVI, you're going to be able to take the image, the near infrared image that we captured before, and all the reflectivity scores that are in that image. We're going to subtract it from the red band of light, divided by near infrared, adding red back in. So we're trying to stretch that differentiation between near infrared, because we know that red isn't going to have as much differentiation, and being able to get you a plant health map back. So what happens? Once you calculate NDVI, once you calculate NDRE, OSAVI, all of that's going to be coming back to a colorized palette. Typically, when we're looking at agriculture, it's a traffic light scale. It's not going to be like thermal, where it's bright white and oranges are hot and blues and purples are cold within that image. You could colorize a map, NDVI map like that, but the industry standard is red, bad, green, good. So green areas are going to be the healthier areas within that map. Doesn't say that it's always healthy, but it's the healthiest areas. And red's going to be the least amount of plant matter in those areas. So from the imagery you capture, we're going to be able to easily convert that into different plant health maps, and you can do that within DJI Terra. There's a number of different indices. These are probably going to be the most common one. Real quick plug for OSAVI, your soil adjusted vegetation index for those early season flights. But later in the season, mainly working with NDRE and NDVI. Let's go ahead. Hopefully this video loads. Not looking promising. It's a pretty short video either way. Just highlighting that you're able to fly, capture it real time. We are processing the NDVI real time on board, but all the imagery is saved. You process it with Terra, and all of your data, since you have RTK module, it's all going to align to your as applied data, so you can just overlay it super easily, a plant health map. There are some use cases for RGB camera reconstruction. There's just a quick screenshot showing you a drainage problem or a drainage issue. We did some subsurface drainage last week, and we were able to just use the normal camera and be able to create a really high quality map and model from that. So it's not all just about plant health with this drone. You can go out and make a really good 2D map, DSM 3D model with this drone too. Some of the advantages, it's an all-in-one platform. You really aren't going to get a drone with gimbaled multispectral for anywhere close to this price, or and especially with that price, anywhere close to that accurate. No calibration panel is necessarily required. You can use one, but we do have an incident light sensor to be able to capture that. High resolution, we're capturing 20 megapixel imagery rather than just 2 megapixel imagery, and then each band is at 5 megapixels. Since I'm behind, let's keep running. You're going to be able to utilize this drone with a number of different use cases. So research, plot, measurement, you're going to get very high GSD, which is something that they're asking for with machine learning to understand different stressors or different types of plants. You're getting good spectral accuracy to be able to understand tracking of growth over time. And then with the RTK module, all of your plots are going to lay in sub-inch accurate, no real need for ground control points. You can obviously use them if you want to check against that accuracy though. Orchard management. So you're going to be able to fly over and understand both off of the high resolution RGB and potentially some spectral analysis. But even with that high resolution RGB, you can process it with fruit tree analysis on Terra. It's going to put a central location for each tree, and then from there, some quick digging, maybe even plug it into QGIS, you're going to get a true count of what those trees are. So not just understanding the number of trees, but also you can break it down into canopy size when we look at multispectral, and then overall change over time with some of these trees. So cotton emergence counts. Once again, we've found so much need for high resolution, high quality visual imagery for agriculture, not just spectral imagery. So can we train machine learning on what a small cotton plant looks like, what a corn plant, what a soybean plant looks like for emergence, so that after planting, we can go in there, fly, and be able to make a map to understand how the corn plants, how the cotton plants came out of the ground, what was the emergence rate, do we need to go back and replant? And before, we couldn't do that with the Phantom 4 multispectral because we didn't have the high enough resolution. You could do it with a Phantom or a Mavic, but then once it came to the real time of the growing season, then you don't have anything for spectral. So cotton emergence, being able to utilize platforms like our smartphone platform or even Agrimo, AgriScout, I think even Drone Deploy is doing some of it, but more with visual, high resolution. There's a lot of value there. And that's why we had both sensors or both approaches to sensors on this drone over the Phantom. So disease detection, a developer's case. Disease detection can obviously be found within spectral analysis, flying over, understanding NDVI, NDRE, walking to those problematic areas of the field, understanding what the problems are. But once again, high resolution GSD from the visual bands of light, we're able to understand different blights that are within these plants here from just the RGB, and then give back a representation with all of these points on the map, showing you where you may have some of the problem areas. Expect to see quite a few use cases come out in 2023 going through a lot of this. And then variable rate fertilization. My daughter is crying at the door, so hopefully I can get my wife down here. Anyway, variable rate fertilization. So being able to fly over the field and be able to, with the spectral analysis, understand how those crops are growing. So you're able to fly beforehand, generate a plant health map, generate a prescription map off of the plant health map. Obviously, you need to ground truth it, build a prescription for fertilization, and then you can go ahead and put that, export it out of Smart Farm and put it into the equipment straight out. So I apologize. The workflow, once more, again, fly, understand the site, same day generate a prescription map, kick it out to that ground-based rig. Hey, if you've got an Agris, that's perfect. But honestly, adoption, probably with the multispectral is going to be, we've got a 90-foot, 120-foot boom sprayer spreader. We're going to be able to plug the prescription directly into that and apply where we need to apply fertilizer or chemical. So Mavic 3 multispectral, big improvements on variable rate fertilization and prescription map making. And you can see some stats down at the bottom about rice farmers and how much they were able to save on some fertilizer use. I think we only have a couple more. We've got growth regulators on cotton. So that it's a very important part for cotton to be able to dry down, die at the same exact time pretty much, so you can come in there and harvest. You can see fly, analyze with Terra, make a prescription within Smart Farm, kick it out to that ground-based rig. And that can be done literally within hours so that you are applying where it needs to go. When you have high value crops that need to be done at the same time, high cost of chemical, high cost of fertilizer, especially in today's day and age and not what it was the past previous years, what you're applying and how you're applying it is way more and more important. And so with the Mavic 3 multispectral, let's improve that workflow. Spot spraying within cotton field. The one thing I do want to highlight is with this VRA map, that's something that was flown with an Agris. So you can see all of the white lines are, all of the lines are where the drone flew, and all the green areas is where the drone turned on spraying, and all of the white areas where the drone turned off spraying. So if you are looking for spraying herbicide within a field, I did the same exact thing with volunteer corn in a soybean field. You're going to be able to generate a prescription map and only spray those plants, so limit the amount of herbicide and the potential chemical runoff. And obviously, flying it with an Agris, you're going to be saving a bit on yield benefits by not driving through the field. And we can get into forest. So it's not just about agriculture. We've talked a lot about ag, but when we're looking at spectral analysis, if we have any sort of insects or disease taking over a certain section of forest, you're going to be able to understand that much easier with the Mavic 3 multispectral. Mission planning is going to be easy. Data collection obviously is going to be pretty easy too. Processing it then within Terra and then outputting it into whatever platform of choice that you want for that forest assessment, where we're giving you all the plant health layers that you're going to be needing. A couple more photos showing you here, just general RGB, even NDVI, not getting a whole lot of variability within. But if you are looking at some of the other plant health indices like LCI leaf area, or OSAVI, getting into soil adjusted vegetation index, we're getting a lot better response, understanding where our problematic areas may be within forest. One last thing, we do have a couple people on staff, so we're going to run through care and maintenance. We're probably going to stay a little bit after for questions, but we do have water quality monitoring. Once again, it's not just about agriculture. Wanting to be able to fly over an area, understand the environmental impacts that have already taken place and the environmental remediation that may need to take place if we're flying time and time again. So we see some algae bloom potentially here, some of the pollution, it's really hard to understand from just RGB, but when we get that large differentiation in reflectivity between near infrared and the visual bands of light, we're able to understand much higher quality or much deeper of if there is any pollutants or any, maybe it's a invasive weed species that you also want to be able to track. There's a lot of different use cases within the enterprise space for water quality monitoring, or those low laying areas. All right, that was a mouthful. We're only 8 minutes till, but we do want to run through a little bit of DJI care and maintenance. Do we have anyone else on DJI team to be able to help with that?
Hi, Kyle. Can you hear me?
I can. Thanks a bunch, Edward. I'll let you take it away, and you can just tell me to click next on the slides.
Sure, thank you. So hi everyone, this is Edward from After Sales team in DJI North America. Here we go. So this is the DJI Care Enterprise plan for the Mavic 3 Multispectral. As you can see, there's not too much difference between this one and the M3E, the Enterprise series. So we have the DJI Care Enterprise Basic Renew, Basic 2-year plan, and the Enterprise Plus and the Plus Renew. So all of the plan covers the crash and collision damage, signal interference, water damage, and other accident caused by user error. So the highlight here for the basic, it covers 2 low price replacement for 1 year. It got the DJI Care Express, the free maintenance. And if you renew it for the 2nd year, you got 1 low price replacement for 1 year. And you also have DJI Care Express supported and extended warranty period. And if you buy the 2-year plan in advance, you got 3 low price replacement for 2 years, and you got all the DJI Care Express free maintenance and also the extended warranty period. Now for the Enterprise Plus, for the 1st year one, it got unlimited free repair and replacement services within the coverage amount for 1 year, and it supports the free maintenance. And if you renew it for the 2nd year, you still have the unlimited free repair, but it should be within the coverage amount for 1 year. Can we go to the next? Thank you. So for the DJI Care activation, you go to this website here, service.dji.com/care then active. The process very straightforward. You bind the code there, but we do have some purchasing and binding conditions. For basic and the basic 2 years plan and the plus, you need to meet at least one of the following conditions. It's either a brand new and unactivated drone, or a drone that has been activated for less than 72 hours, or if you use the DJI Care Express, you receive a replacement unit. It should be less than 72 hours have passed after the DJI enterprise device was repaired by an official DJI service center. Now for the renew, for basic, you have bound your product to DJI Care Enterprise Basic, and your DJI Care Enterprise package has not expired, and your DJI Care Enterprise plan has at least one product replacement left. For Plus Renew, you have it has to bound with the DJI Care Enterprise Plus, and your DJI Care Enterprise package has not expired, and at least 30% of the coverage amount is left. And one thing to notice, they cannot cross renew. Like if you had the basic plan at the beginning, you cannot renew it to a plus, or if you had a plus at the beginning, you cannot renew it to a basic plan. Yeah. Can we go to next? Yeah, so this is the workflow of our online repair request. So you first go to this website, then it's very straightforward. You do the data backup first, then do the repair application, send to us, and we do the repair and send it back. One thing to notice, you can choose your payment method for DJI Care Enterprise in the step of inspection and payment. Yeah. And if you had the basic plan, you would have the option to do the DJI Care Express request. You go to the DJI Care Express website, and yeah, again, it's very straightforward. You do submit the online repair request, then you pay a one-time service fee, replacement service fee, and then once we receive the damaged unit, we ship out a replacement unit to you. Yeah. So here's the maintenance program for M3M. For the basic, we included the deep cleaning, parts inspection, and update and calibration. On top of that, for the standard plan, we do cover the easily worn parts replacement. And for premium, we have the propulsion system replacement as well. And it goes up to 600 hours flight time or 3 years. Next. So for the maintenance application, our drone usually have a free 1-year maintenance program. So you just go to that website and then do the maintenance application. For you to get obtain the DJI Care factory maintenance code, you just go to the scroll down to the FAQ section and fill in the DJI Care factory maintenance service application. Yeah, next. Yeah, so our latest version of the Pilot 2 app, in your RC, you can see the DJI Care section and the maintenance icon on the right corner. So this would give you the function to be reminded when the expiration date of the current service plan is. So if we go into more detail for the next slide. Yeah, so once you click the icon in the Pilot app, it shows you when your DJI Care Enterprise plan will be expired, and it will give you a reminder in red letters when it's close to a month away from the expiration date. And if it's already expired, it will show in gray letter on the right it is expired. And same for the maintenance plan. If you go to the next slide. Yeah, so for standard service, the yellow reminder is 7 days, 50 flight times in advance. For premium is 30 days and 100 flight time. Yeah, as you can see on the right, you could click into the DJI maintenance program icon, and then you can request a maintenance. So it's very convenient for the end user to use this interface. Yeah. I think that's all from my part. Is there any questions for both of us?